The Crag demonstration cell was developed through the interpretation of sim concepts. The 4 workstations are linked by a conveyor system and are under the umbrella of computer control. The demonstration presents computer integration, computer control, safety, flexibility and materials handling. The system is managed by 5 PCs and an industrial PLC linked through a MAC network. MIG welding is performed by an assayer robot. The component is presented to the robot on 2-axis tables. A hydraulic mechanism provides fine positioning and load-unload facilities. A hydraulic ram is raised and power is transferred from the offshoot rollers to activate the rollers on the table. Four hydraulic clamps fix the pallets over the locating cone. A wire feeder and torch were mounted on the upper arm of the robot. A synergic mid-welding power source was controlled by the robot controller. The auxiliary equipment was controlled by the PLC, communicating via input-output signal lines. The engraving station comprises of an air-driven high-speed engraving tool mounted on a Puma robot. Compliance in the robot's end effector easy stress created at the tip tool caused by accuracy limitations. Renshaw probe was mounted onto the IBM gantry robot to simulate a coordinate measuring machine. Communications are via 5 input-output ports. The IBM is able to determine whether the system has presented the correct component by comparing the height of the component in the station with that expected from the system's database. On confirmation, the robot performs a searching routine to locate the center of the component. The lengths of 2 perpendicular diameters and the component's height at 4 faces were measured. The datum is set up on the base of the pallet. Components enter and exit the cell through the manual station. Instructions to the operator were received via a remote terminal. On successful completion of his instructions, the operator informs the control system via inputs at the terminal. The manual area is guarded by a fixed wire mesh surround and light guarding. If the light guard is broken while the station is live, the station is deactivated. The materials handling system consists of a main conveyor loop and 4 offshoots. The main loop is maintained by a lift at either end. The offshoots are served by a transfer car mounted on a pallet. A shock bolt stops the pallet at the foot of the offshoot. Four shock bolts raise the transfer car and actually locate the driver roller to the end roller of the offshoot. Proximity sensors signal the completion of the sequence. The PLC controller. The control area is situated remotely but in visual contact with the cell. The mimic screen graphically represents the cell. Each pallet is uniquely identified on the screen. the system database. The flexibility of the system is represented by rings of 3 different diameters. The selected rings are mounted on a fixture. The pallet is identified by the black Eureka tag.